Good day to Madam Zuraini binti Ghani. I'm Dishala Analaki Morgam and my metric number is 01DKM20F1087 and my group members are Ezhilchelvam Analaki PONNUSAMY 01DKM20F1090, KIRIDHARA Analaki L.RAMALINGAM 01DKM20F1104, MADHAVAN Analaki GUNASELAN 01DKM20F1142. We are from DKM3C. Today we are going to do presentation 1 for Engineering and Society. We are from Group 6 and our topic is number 6, Sustainability and Green Technology. 6.1, Determine Sustainability and Green Engineering. Sustainability is measured by assessing performance of social, environmental, and economic principles. While a balanced treatment of all three is an ideal goal, it is not always achievable. While green engineering is the design, commercialization, and use of processes and products in a way that reduces pollution, promotes sustainability, and minimizes risk to human health and the environment without sacrificing economic viability and efficiency. So these are the short definition for both of it. Moving on, 6.1.1, Explore Sustainability. First, we will look at definition. Second, its origin. Third, as an aspect of engineering disciplines. Fourth, the role of professional engineers in sustainability. Definition. Sustainability is the capacity to endure in a relatively ongoing way across various domains of life. In the 21st century, it refers generally to the capacity for Earth, biosphere, and human civilization to coexist. Despite the increased popularity of the term sustainability and its usage, the possibility that human societies will achieve environmentally sustainable has been shown and continues to be questioned. In light of environmental degradation, biodiversity loss, climate change, overconsumption, population growth, and societies' pursuits of unlimited economic growth in a closed system. Next, origin. Originally, sustainability meant making only such use of natural, renewable resources that people could continue to rely on their yields in the long term. However, the idea itself goes back to times immemorial, as communities have always worried about the capacity of their environment to sustain them in the long term. Moving on to the next slide. As an aspect of engineering disciplines, every engineering discipline is engaged in sustainable design, employing Gary Adams, especially life cycle analysis, LCA, pollution prevention, design for environment, DFE, design for disassembly, DFD, and design for recycling, DFR. These are replacing or at least changing pollution control paradigms. For example, the concept of cap and trade has been tested and works well for some pollutants. This is a system where companies are allowed to play a bubble over whole manufacturing complex or trade pollution credit with other complaints in their industry instead of stack by stack or an pipe by pipe approach. For example, the so-called command and control approach. Most integrable problems are often those that are small but very expensive and difficult to treat. For example, less feasible. Of course, as with all paradigms shifts, expectations must be managed from both a technical and an operational perspective. Now, let's look at the role of professional engineers in sustainability. The guidance describes the role of professional engineers in sustainability. It lists 6 principles to guide and motivate engineers when making decisions for clients, employers, and society, which affect the sustainability. This guidance is issued by the Engineering Council. It replaces and updates the Code of Practice Engineers and the Environment published in 1993. Now let's look at the 6 principles. First, contribute to building a sustainable society, present and future. Next, applying professional and responsible judgment and take a leadership role. Do more than just comply with legalization and codes. Use resources efficiently and effectively. Next, seek multiple views to solve sustainability challenges. And last, manage risk to minimize adverse impact to people or the environment. That is all for me. I will pass it on to the next presenter.
Next, we are going to discover green engineering. First of all, what is green engineering? Green engineering is the design, commercialization, and the use of processes and products in a way that reduces pollution, promotes sustainability, and minimizes risk to human health and the environment without sacrificing economic viability and efficiency. Green engineering embraces the concept that decisions to protect human health and the environment can have the greatest impact and cost effectiveness when applied early in the design and development phase of a process or product. Green engineering approaches the design of products and processes by applying financially and technologically feasible principles to achieve one or more of the following goals: decrease in the amount of pollution that is generated by a construction or operation of a facility, minimization of human population exposure to potential hazards, including reducing toxicity, improve uses of matter and energy throughout the life cycle of the product and processes, and maintaining economic efficiency and viability. Green engineering can an overarching framework for all design disciplines. From the green engineering, we are going to learn about the 12 principles of green engineering. In 2003, the American Chemical Society introduced a new list of 12 principles of green engineering. The first principle is inherent rather than circumstantial, where designers need to strive to ensure that all materials and energy inputs and outputs are as inherently non-hazardous as possible. The next principle is prevention instead of treatment, where it is better to prevent waste than to treat or clean up waste after it is formed. The next principle is design for separation, where separation and purification operations should be designed to minimize energy consumption and material use. The fourth principle of the green engineering is maximize efficiency, where products, processes, and systems should be designed to maximize mass, energy, space, and time efficiency. The next principle is output pull versus input pushed, where products, processes, and systems should be output pulled rather than input pushed through the use of energy and materials. Conserve complexity is also one of the principles of green engineering, where embedded entropy and complexity must be viewed as an investment when making design choices of recycling, reuse, or beneficial disposition. The next principle, which is durability rather than immortality, where targeted durability, not immortality, should be a design goal. The next principle of green engineering, which is meet need, minimize excess, where design for unnecessary capacity or capability solution should be considered a design flaw. Minimize material diversity, which is also one of the principles of green engineering, where material diversity in multi-component products should be minimized to promote disassembly and value retention. Integrate material and energy flows is also one of the principles of green engineering, where design of products, processes, and systems must include integration and interconnectivity with available energy and material flows. Design for commercial afterlife is the 11th principle of green engineering, where products, processes, and systems should be designed for performance in a commercial afterlife. Renewable rather than depleting is the last principle of green engineering, which states that material and energy inputs should be renewable rather than depleting. The next subtopic which we are going to learn is classify sustainable and green technology. First of all, let us go in detail about the meaning of sustainable and green technology. Green tech refers to a type of technology that is considered environmentally friendly based on its production process or its supply chain. Green tech, an abbreviation of green technology, can also refer to clean energy production, the use of alternative fuels, and technologies that are less harmful to the environment than fossil fuels. Although the market for green technology is relatively young, it has garnered a significant amount of investor interest due to increasing awareness about the impacts of climate change and the depletion of natural resources. Green technology is an umbrella term that describes the use of technology and science to create products and services that are environmentally friendly. Green tech is related to clean tech, which specifically refers to products or services that improve operational performance while also reducing costs, energy consumption, waste, or negative effects of the environment. The goal of green tech is to protect the environment, repair damage done to the environment past, and conserve the Earth's natural resources. Green tech has also become a burgeoning industry that has attracted enormous amounts of investment capital. The use of green tech can be a stated goal of a business segment or a company. These goals are typically outlined in a company's environmental sustainability and governance in bracket ESG statement, or can ever be found in the mission statement of a firm. Increasingly, socially responsible investors are looking to narrow down their prospective investments to only include companies that specifically employ or produce green technologies. Sustainable technology is an umbrella term that describes innovation that considers natural resources and fosters economic and social development. The goal of these technologies is to drastically reduce environmental and ecological risk and to create a sustainable product. Sustainability in technology can be defined in three ways. The first defined is substitution, where the technology fosters a shift from non-biodegradable to biodegradable materials in its production. It also replaces non-renewable with renewable resources. Secondly, prevention is one of the sustainability in technology, where the sustainable technology prevents deterioration, contamination, and other negative environmental impacts through its use or production. The last sustainability in technology is efficiency, where the technology is efficient in terms of its use of energy and resources. The next part that we are going to learn in this subtopic is illustration of the model of sustainable development. First of all, let us look into the model of sustainable development, which is shown below, which is the overlapping circle model. The overlapping circles model of sustainability acknowledges the intersection of economic, environmental, and social factors. Depending on our mindset, we resize the circles to show that one factor is more dominant than the other two. For example, some business leaders prefer to show the economy as the largest circle because it is the most important to their success and it makes their world go round. They draw society as the second largest circle because that is where their customers and other important stakeholders live. The environment would then be the smallest because it is the most external to standard business metrics. Unfortunately, this model implies that the economy can exist independently of society and the environment, that the part of the red circle that does not overlap with the blue and green circles as an existence of its own. This large incongruity leads us to the next more accurate model. The emergence of the sustainable development concept as the response to the mining of natural resources for the benefit of multinational corporations has advanced the cause of long-term environmental management. A sustainable development model (SDM) framework that is inclusive of the whole natural environment is presented to illustrate the integration of the sustainable development of the whole ecosystem. The ecosystem approach is an inclusive framework that covers the natural environment, relevant features, and constraints. These are dynamically interconnected and constitute the determinants of resource development component of the SDM. The second component of the SDM framework is the resources development patterns, which are the use of land, water, and atmospheric resources. All of these patterns include practices that utilize environmental resources to achieve a predefined outcome, producing waste and byproducts that require disposal into the environment. These water quality management practices represent the third component of the framework. These practices are governed by standards, limitations, and available disposals, means subject to quantity and quality permits. These interconnected standards, practices, and permits shape the resulting environmental quality of the ecosystem under consideration. A fourth component, environmental indicators of the SDM framework, provides a measure of the ecosystem productivity and status that may differ based on societal values and culture. The four components of the SDM are interwoven into an outcome assessment process to form the management and feedback models. The concept of sustainable development is expressed in the management model as an objective function subject to desired constraints, imposing the required bounds for achieving ecosystem sustainability. The development of the objective function and constraints requires monetary values for ecosystem functions, resources development activities, and environmental costs. The feedback model ensures policy and resource use changes required for sustainability. And iterative process would be required to define the optimum ecosystem development plan that satisfies sustainable outcome.
Hi, I'm going to talk about the role of engineer towards sustainability and green technology. First of all, I'm going to define engineering and development as a quick explanation. Engineering is defined as a discipline, art, skill, and profession of acquiring and applying scientific, mathematical, economic, social, and practical knowledge. This is to design and build structures, machines, devices, system, material, and processes. Development can be called the sum of a product and project. In this application, engineers carry out, influence, or decide the option evaluated, the decision-making criteria, the decision, and the detailed design and implementation. For development to become sustainable, engineers must incorporate sustainability into the planning and engineering of product and projects. Technology is neither good or bad itself. How we choose to apply it determines whether a good balance is achieved. Engineers integrate with all aspects of a society. It takes concepts from maths and science and puts them into a context through social economic consideration before implementing them as a tangible outcome in this society. It is essential that engineering understands social and environmental constraints and does not just conform to economic necessities. The purely business influence has been the paradigm of engineering, which has led to a lot of problems outlined above. An engineer has a duty to implement the knowledge of how the world works to design systems, processes, technology that will benefit humanity. Humanity faces grave challenges in survival as knowledge of these challenges and a willingness to solve them must be reflected in an engineer's duty to society. In making the world sustainable, a key concept is design. We need to design how society, the economy, and the environment can all function as a holistically and symbiotically without one detrimentally affecting the others. Fundamental part of engineering is design. As such, it will be engineers, integrated and embedded society that can use their skill to steer humanity away from collapses to a bright and optimistic future. Next, I'm going to break down some environmental issues. Our environment faces several problems, and many of these seem to be worsening with time, bringing us into a time of true environmental crisis. It is therefore becoming increasingly important to raise awareness of the existence of these issues, as well as what can we do to reduce its negative impact. I'm going to explain about some key issues of environmental issues. First of all is pollution. Pollution of the air, water, and soil caused by toxins such as plastic, heavy metals, and nitrates, caused by the factors such as toxin and gas released by factories, combustion of fossil fuels, acid rain, oil spills, and industrial waste. Next is global warming. The emission of greenhouse gases due to human activity causes global warming, which in turn causes an increase in temperature that leads to rising sea levels, melting of polar ice caps, flash flood, and desertification. The third one is ozone layer depletion. Pollution caused by chlorofluorocarbon (CFC) in the air creates a hole in the ozone layer, which protects the Earth from harmful UV radiation. Moving on to overpopulation, we are facing a shortage of resources such as food, water, and fuel to sustain the rising global population, particularly in developing countries. Intensive agriculture attempting to lessen the problem actually leads to more dangerous through the use of chemical fertilizer, pesticide, and insecticides. The fifth one is loss of biodiversity. Species and habitats are becoming extinct due to human activity. This causes an imbalance in natural processes like pollination, poses a threat to ecosystem. Coral reef destruction is particularly affected. The sixth one is waste disposal. An excessive amount of waste is produced and dumped into the ocean. Nuclear waste is particularly dangerous as well as plastic and electronic waste. And the final one is acid rain. Pollutants in the atmosphere such as sulfur dioxide and nitrogen oxide cause acid rain, which has negative consequences for humans, wildlife, and aquatic species. I think that is all from me. Thank you.
Now, I will be presenting about invention and innovation towards sustainability and green technology. The first invention is vertical farming. When it comes to green innovations, vertical farming is a revolutionary technique that reaps the yield in simple fashion was first set up in Jackson, Wyoming. This farming type is known as the vertical harvest farm and is a 3-storied hydroponic greenhouse on a 30 by 150-foot plot land. This farm is capable of producing 37,000 pounds of greens, 44 pounds of herbs, and 44,000 pounds of tomatoes without the use of any pesticides or chemicals. The idea behind this setup was to eradicate the fast food culture people resort to when they don't find fresh food. These vertical farms are weather agnostic and can also adapt to impending disasters. The concept has since been replicated at multiple occasions. Next is emission-free transportation. Many initiatives have been taken to reduce the number of carbon emissions from vehicles and automobiles, most which revolve around the usage of cleaner fuels. Among such green innovations, one is solar-powered electric bikes. These bikes have solar cells on the wheels that absorb the sunlight and process it to transfer the kinetic energy directly to their batteries. On a full charge, they can go up to 30 miles per hour. It is important to encourage people to drive less and use bike more. Electric cars are gaining stands in the automobile industry and their sales are soaring as well. The governments across the world have been working towards the improvement of the EMVs and also providing subsidies to increase their sales. Next is hydroelectric power station. Hydroelectric energy, also called hydroelectric power or hydroelectricity, is a form of energy that harnesses the power of water in motion, such as water flowing over waterfall, to generate electricity. Most hydroelectric power plants have a reservoir of water, a gate, or valve to control how much water flows out of the reservoir, and an outlet or place where the water ends up after flowing downward. Water gains potential energy just before it spills over the top of a dam or flows downhill. The potential energy is converted into kinetic energy as water flows downhill. The water can be used to turn the blades of a turbine to generate electricity, which is distributed to the power plant's customers. Last but not least is solar cooker. We use a solar cooker for cooking the food by using the energy radiated by the sun. Solar cooker works on the principle that sunlight warms the pot, which is used for cooking the food. Now, this warming of the pot occurs by converting light energy to heat energy. Concave mirrors are used in these types of cookers because these mirrors reflect sunlight into a single focal point. Here, the mirror focuses sun rays onto a receiver such as a cooking pan. A solar cooker lets the UV light rays in and then transforms them into longer infrared light rays that cannot escape. Infrared radiations have the energy to make the water, fat, and protein molecules in food vibrate energetically and heat up. The process by which the interaction between the light energy and the receiver material turns light to heat is called conduction. We can maximize this transformation by using materials that can conduct and retain the heat. Next is contribution of engineers towards millennium. Engineers contributed very significantly to a country's development from an agricultural economy to one that includes manufacturing, communication services, and exploitation of the country's natural resources like tin, hydropower, oil, and gas. They build the infrastructure and the tools necessary for progress. Without road, highways, bridges, clean water supply, electrical power supply, telephone communication, we will feel like living in the jungle. Engineers also forecast and plan for future water demands and make proposals to solve current water supply problems. For an example, proposal of building new water treatment plants and reservoirs or replacement of old pipelines to reduce losses due to leakage and so on. All these were developed and built with the input from engineers. Engineers also help in providing good public transportation network which enhance country image. Moving around in big city in Klang Valley using light rail transit and monorail system can avoid the congestion of traffic, overcome the problem of scarcity of car parks, and shorten the period of time to reach the destination. Engineers provide solutions for limited space in a city by efficiency of interchange, solve foundation and stability problem, carry out value engineering for optimization of costs, which make more development for limited capital a nation has. The improvement in the telecommunication contributed by the engineers in the field of electrical, electronic and computer engineering have resulted to a better quality of lives. Satellite TV and cell phones together with computer and internet have enabled us to communicate instantly and anywhere on earth so that we are how more informed than ever with the information that can be searched for and accessed more readily. One can communicate with your friends, family members, business partners, or clients at any place and at any time.
The final part of the presentation is the conclusion part. In a conclusion, we have learned three subtopics from this presentation. The first subtopic is determine sustainability and green engineering, where we gained information about the exploring sustainability and discovering green engineering. The second subtopic, which is classify sustainable and green technology, where we are able to illustrate the model of sustainable development and also the structure Malaysia Green Technology Master Plan. In the third and final subtopic of the presentation, we are able to correlate the role of engineer towards sustainability and green technology, where we are able to break down environmental issues, discover invention and innovation towards sustainability and green technology, and also determine the contribution of engineers towards new millennium. With this, we are able to make the conclusion of the presentation. I think that is all about the presentation. Hope you all enjoy it. Thank you all for lending me your ears.